Problem number 4. Four identical rods, each of mass m and the length 2d, are joined together to form a square. The square is then spun around its center as shown in the figure at an angular frequency of omega. What is the magnitude of the force that the joints between the rods at the corners of the square must bear? Solution for problem number 4. Consider a rightmost rod and consider an arbitrary point dy on this rod, as on a presented diagram. The centripetal acceleration at that point is given by formula radius vector for acceleration equal negative omega square radius vector for this point, which is in other form is negative omega square d on axis x and y on axis y. So it means that the rightward component of centripetal acceleration is omega square d, which is constant along the rod. Thus, the rightward force on the rod is negative m omega square d. In the direction y, due to symmetry, centripetal force is cancelled. Using Newton's third law and the symmetry, we see that the tension in each joint must be in the direction perpendicular to the corresponding diagonal. Thus, we can set up a free body diagram equation for each rod with the two forces at the joints and the centripetal force. Since these forces must cancel, we get 2F cosine 45 degrees equal FCX. And from here we can find that force F equal m omega square d over square root from 2, which is answer B, and that was solution for problem number 4. Problem number 5. A pendulum of length L oscillates inside a box. A person picks up the box and gently shakes it horizontally with a frequency omega and a fixed amplitude for a fixed time. The final amplitude can be maximized if omega satisfies next one. Solution for problem number 5. In the frame of the box, this is equivalent to a horizontal driving force with a frequency omega. To increase the amplitude, the driving should be at a resonance. So, omega equals square root from G over L, which is answer B, and this is the solution for problem number 5. Problem number 6. A planet is orbiting a star in a circular orbit of radius r0. Over a long period of time, much greater than the period of the orbit, the star slowly and steadily loses 1% of its mass. Throughout the process, the planet's orbit remains approximately circular. The final orbit radius is closest to which one? Solution for problem number 6. The angular momentum equal to mvr is conserved. Moreover, since the orbit is always circular, the kinetic energy and potential energy are related by 2k equal negative u. It means that mv square equal gm big M small over r, where big M is the mass of the star. It means that mass of the star proportional to v square multiplied by r, which is proportional to L square over r, where L is conserved. It means that 1% decrease in the star's mass gives a 1% increase in the orbital radius, which is answer B, and that was solution for problem number 6. Problem number 7. An astronaut standing on the exterior of the International Space Station wants to dispose of 3 pieces of trash. They face the station's direction of travel with the Earth to the left. From the astronaut's perspective, the three pieces are thrown first left, second right, and third up. To the astronaut's frustration, some of the pieces of trash return to the space station after several hours. They are next one. Solution for problem number 7. By Kepler's third law, we have t squared proportional to a cubed, where t is a period of orbit and a is the semi-major axis. And also we have total energy E equal negative G big M small m divided by 2a. The astronaut's throw has a negligible impact on the total energy of the trash, and hence a negligible impact on A and hence T. In fact, after one full orbit, all three pieces of trash simply return to the space station. That's answer E, and that was solution for problem number 7.